right, I am going to demonstrate the comprehensive meta-analysis software for you so that you can see what the program looks like, and I'm going to use a running example in demonstrating this for you. And essentially you are going to see what the data looks like when it's fully entered into CMA. And then I'm going to show you how to run the analyses. So you're going to be able to see the forest plot within the context of an example, and I'm going to show you where you find the summary effect size and broad strokes of how to interpret the forest plot. I'll show you how to run the heterogeneity analysis and find the dispersion values, and then I'm also going to show you how to run the moderator analysis. So without further ado, let's bring up CMA. All right, now as you bring up the program, what's going to happen is you are going to see this welcome window here, and it's going to ask you what you'd like to do. And you want to open an existing file. Now your group is going to be sent your CMA spreadsheet of data already entered that you entered into Excel last week. And so you'll be able to find your data and click on that and open it, and that opens your data that's entered into CMA. Look at that. So I'm actually going to show you a previous iteration of this course. There was a group that looked at anger management. So the specific project examined the effectiveness of CBT for treatment of anger over time with offenders in a number of different types of settings. And so their problem statement was, is CBT an effective treatment for reducing anger with prison-based offenders and community-based offenders? What characteristics do other common and uncommon treatment programs have? And how effective are CBT treatment programs with these populations, and do they actually reduce anger over time? All right, so let's take a look, and there's a lot going on here. So I'm going to show you the basics of your data that's entered into CMA, and then we'll go on to the forest plot next. So you can see here on the left-hand side that the first variable we see is study name. So most of your groups called this the author category, and you've got just the first author's last name. We actually edit this column for entry into CMA because we want it to appear with the year, and if it's got multiple authors we use et al. So it just looks a little bit more formal in terms of a study name within CMA, and you'll see why we do that when we see the spit out of the forest plot. And then we have our effect size data in all of these fields here. Okay, so you see that they have a total of 9 articles that were included in their analysis, and the first 8 articles actually look at means and standard deviations of both a treatment and a control group. So they examined the changes in post-test scores between the treatment and control groups. So they had means, standard deviations, and then sample sizes for both groups. Now, you'll notice that the 9th article here actually used a different type of data for the effect size, and it's grayed out and you can't see the data. That's because CMA only allows you to view data in one type at a time, and it grays out the other information. But it's still there, but if you want to look at it, you just have to go down to the bottom and click that tab there. So if we want to look at that data, we can see that they had to use an independent group's t-value and a sample size for both the treatment and control groups in order to get the effect size there. And then you see that the rest of the data gets grayed out while we're looking at this 9th article. So let's go back to the main data where most of our data is viewed. And then so after that data shows us what they use to compute the effect size, all of this yellow area is actually our effect size calculation data. Now remember, if we're looking at effectiveness of treatment and change in a particular symptom over time, we're going to be looking at a Cohen's d, and we're going to be looking at calculating that into a Cohen's d. We're going to transfer that over into a Hedges G to avoid the bias in sample sizes, and then we're going to again move it back to a Cohen's d. And it's too complicated to get into all of the ins and outs of why we do that. We just do it. And then over here beyond the yellow, we see some other variables. So any other categorical variables that your group looked at, these are going to be your potential moderator variables that you can examine to determine where the heterogeneity is coming from when we can look at that. And in order to run moderator analyses, you need to make sure that that particular variable has enough variation in it. All right, so there needs to be enough variation there. So for an example, let's look at country. All right, they only had two codes, 1 and 2. So 1 represented the US, 2 represented international studies. All right, so you can see here that they have 3 studies that were in the United States and then 6 that were outside of the United States. So 6 versus 3. It's not an even split, but there is variability there. And so we can run moderator analysis on that variable. All right. So let's run some analyses and see what we get. All right. So you've got your data here. You know what's in here. And the first step that we take is we go up to this Run Analyses button with the arrow, and we just press that rectangle once. And you'll notice that it thinks for a little bit, and then it brings you to this new screen where you see a forest plot. All right, now before you look at anything in detail and get super excited, make sure that you remember to go down to the bottom and move it over to a random effects model, because again, everything that we're doing in psychological research should be within a random effects model. So now we've got it in the random effects model, and you can see our forest plot here. But we're actually going to make it really pretty, and we're going to put it in a PowerPoint file that's going to be able to be exported for your final presentation, because this is what you want to present and discuss and have me ask you questions during the final presentation. So to do that, you're going to click on this high resolution plot button here, and that is going to generate your forest plot. Now you can decide if you want it in black and white, or you can also change it into a colorful version. All right, I will let you all decide. You can even take both if you decide that you want both, and fight it out which one you want to use. But you'll want to make a few modifications to the table so that it makes sense for your group. So here it says favors A and favors B. So let's say that you're looking at treatment effectiveness. You're going to right-click over favors A, and it brings up a box and it allows you to change those labels. So we're going to type in here favors treatment, and then on the right-hand side is where it favors control. And so we're going to add those. Then we're going to click the button apply, and they appear there. We can also change the size of the text that appears. So if you'd like that text to be larger so that it's a little bit more readable, you can do that. All right. We're going to make it a little bit smaller so that you can tell that there's a clear separation between the favors treatment and the favors control side. So there. And then you'll also want to add a title. So to do that, you would right click And you would then add your header and fix the font and everything that you want there as well. All right, and you'll be able to export this file, and instructions are in the how to run your data in CMA PDF. All right, so let's go back to return to table after you have looked at the forest plot. Okay, now again, okay. I did mention that I was going to show you what's going on in the forest plot very briefly, so I will do that here. So again, remember that in the forest plot there's a lot of data, but on the left-hand side we have our study names, all right? And we also have our Cohen's d, so our standard difference in means value. We have our standard error, our variance, our upper and lower limits, so the confidence interval, our z-value, and then our p-value, which tells us whether or not it's significant. And you will notice that there is data for each individual study, so of those 9 studies, but then you also notice that there's a line at the very bottom below, so not attributed to any particular study. Now that data is related to your mean or summary effect size. Okay, so the mean effect size for this particular meta-analysis was negative 0.726. All right, and we can see that the p-value was 0.002, so that was a significant effect size at the p is less than 0.05 value. All right, so essentially, yes, these programs that were examined in these 9 articles overall demonstrated that treatment was effective for reducing anger over time. Now we also see the forest plot here over on the right. Now there's a lot going on, but there are a few things that you need to know when interpreting a forest plot. So this line here in the middle at 0 is actually called the line of no effect. All right, it's important for you to remember that. That's the line of no effect. And what that means is that when one of those boxes, when one of those effect sizes crosses over to the right-hand side of that line of no effect, that essentially means that the treatment group performed worse than the control group. Okay, so the control group performed better than the treatment group in that instance. All right, that's why it says favors control on the right-hand side of the forest plot there. And so what does that mean for the 2 effect sizes that are on the line of no effect? That essentially means that they came out about even. There's no difference between the treatment or the control group. Now you can see that those boxes are just a little bit to the right of the line, but still kind of sitting on it. So, you know, they're right at that line. But that's what that means when an effect size is actually sitting on the line of no effect. But you do notice that for the rest of the studies, they are all to the left of the line of no effect. And so that's showing that they favor treatment. So treatment is showing a reduction in symptoms. And actually, the further the box is away from the line of no effect, the larger an effect size, so the larger a reduction of anger there was. Okay. Now, the last thing that you need to know on this forest plot is this rhombus here at the bottom. Okay. This rhombus actually represents the mean or summary effect size. Okay, so the top and bottom points of that rhombus is actually right where the effect size is, so at negative 0.726. And then the left and right points of the rhombus actually represent your confidence interval. All right, so the lower limit is at negative 1.189. The upper limit is at negative 0.263. All right, so that shows you the basics of what's going on with this forest plot. Now we're going to go back to the table, and we're going to run our heterogeneity analysis. All right, so in order to do that, we just have to go back to the table, so back to where we are here, and then we hit Next Table. All right, now you're going to want to take a screenshot of this, and depending on your computer, it may have a different function, but all we do is Shift Print Screen, and I'll take you to that when we get to that in just a second, but let's look at what's going on with the heterogeneity analysis. So this is what the printout looks like, and you can see that you can see both the fixed and random effects models. All right, we can see that there were 9 studies that were evaluated, and the point estimate is another fancy term for the mean or summary effect size, and that was negative 0.726. We've got all of our other measures of heterogeneity here. We've got a p-value of 0.002, again showing that that effect size was effective. And here we have our heterogeneity values. Now you're sort of probably wondering, well, why are there not heterogeneity values on the random effects line? So our heterogeneity values are actually calculated within the fixed effect model. And so it's okay, they're going to appear on the fixed effect line, even though you are in a random effects model for your analysis. So we can see here that the Q value was 45.925, so that's showing a decent amount of variability among those 9 studies with a degrees of freedom of 8. And we see that the p-value here is 0.000, so that does mean that the heterogeneity is significant. So these studies are different from one another. There is variability present. All right, and so because that heterogeneity is significant, we need to do further analysis to explore how we can try and account for that variability. Now, before we move on to that, I'm going to show you how to pull over the screenshots into a Word doc. But again, you're tau squared, so really t squared, we don't ever truly know what the true value of tau is at any given point. So we're really looking at t and t squared, but those dispersion values are there, and you have information in your notes as to how to interpret those, as well as your I squared. So let me just show you really quickly the best way to pull over your screenshots. So I did Shift Print Screen, so it's on my clipboard. I've gone into Word, I've opened a blank doc, and I've put the orientation at landscape. And all I do is paste it in there, so Control V, and that gives me my screenshot. I go ahead and crop the image so that I'm just looking at what's necessary. And then once that image is cropped, I'm able to add a label to it. All right, so this shows us our overall analysis, and then it also shows us our heterogeneity analysis over on the right-hand side. So we're just going to leave that there, and we're going to go back into CMA to run our moderator analysis. All right, so we're still on the screen where we have our heterogeneity output, and so how do we do our moderator analysis? So you would think that you would go to the Analyses tab, but actually the only functions there are publication bias and meta-regression. So we're actually going to go to Computational Options, and we're then going to go to Group By. And so you may be able to remember that that's that function because it's moderator or subgroup analysis. So group is that key. So go to Group By, and then this window is going to pop up. And you're going to be able to select one of the moderators that you have in your database. All right. So your assignment is to run 2 analyses, and you want to try to find variability and explain it if you can. So you may have to run a few to try and find some significance. Let's look at research design. So I'm going to show you how to do this. So you're just going to select a variable. So first we're going to look at research design, and we want to click both of these boxes. So also run analysis across levels of design and compare effect at different levels of design. And then we're going to hit OK. And here we are. Here is our moderator analysis for research design. So again, I'm going to do Shift Print Screen, and I'll take it over to the other screen in just a moment. But now you can see that we have a lot more data on this page, so we need to sort of make sense of what's going on here. So you'll notice that on this page we now have fixed effect analysis and mixed effects analysis. All right, so when looking at the moderator analysis, we want to be looking at the mixed effects analysis. You are still in a random effects model. You can tell at the bottom of the screen it shows you that you're in a random effects model. But for some reason, CMA calls it a mixed effects because it still accounts for the fixed effect piece of it. But just remember, you are in a random effects model. All right, and so what is this showing? So this showed that it ran the analysis based on this subgroup. So it looked at studies that were RCT based in design. So that was code 1. So there were 5 studies that were RCT. And then the other type of study that was examined was quasi-experimental, and that was code 2, and they had 4 articles that were that. And so what it did is it looked at the difference in effect sizes for those articles by that grouping. And so we can see that the effect size for RCT studies was gigantic. Look at that, -1.181, versus the quasi-experimental studies just showed an effect size of -0.2. Now that's still a small effect size, but it's quite different in relation to the huge -1.18. And so how do we know if this is effective? So we can tell by looking at the p-values here. So if you look at this, okay, so this p-value here at 0.000 shows that those RCT studies were effective. Okay, they were definitely different from the quasi-experimental studies. And we can see that there is a 6.020 heterogeneity value here. So what that means is we have accounted for 6 of the 45 existing heterogeneity. Okay, and the p-value for heterogeneity is 0.01. So again, it's significant because it's less than 0.05. So this is a significant finding here. So RCT studies definitely showed a significant reduction in anger symptoms over quasi-experimental studies. And it accounts for 6 of the 45 of heterogeneity that was found. All right, so again, we're going to bring that over into our Word doc. All right, so we are going to give a little bit of space here, and we're going to do Control V. And we're going to again crop this image so that we have just what we need. And then we're going to add a label so that we remember what it is that we ran. So this was moderator analysis for the research design. And then I like to label what the codes are at the top so that you remember when you're sitting there and you're trying to interpret this, and you don't have to go back to your coding manual or across a number of different documents. So 1 as RCT and 2 as quasi-experimental. And there you go. And that's your first moderator analysis pulled. Let's go back into CMA and do one more moderator analysis. So here we're on that moderator analysis screen. All we have to do to run another one is, again, go back up to computational options, select group by, and then choose another variable. So this time we're going to run treatment setting. And we're going to again click these 2 boxes and hit OK. And here we have our treatment setting moderator analysis. And again, I'm going to screenshot this so that we can pull it after we're done looking at it. But here, again, we're going to be focused on the mixed effects analysis piece. All right, so let's look at what these codes mean. Okay, so remember that they were interested in looking at effects of anger management treatment in different types of treatment settings. So the first code, number 1, was actually looking at correctional institutions. Code 2 was community-based settings. Code 3 was inpatient hospital, and 4 was any combination of the above settings. Okay. And we had some variability here. So we had 5 articles that looked at correctional settings, 1 that was community-based, 1 inpatient, and then 2 that were describing any combination of the above. And again, we're seeing here that 2 of the 4 were significant. Okay. So that was correctional settings and community-based settings. All right. And we can also see that the heterogeneity here is quite large. So look at how much we're explaining. 36 of the 45 there is coming from just treatment setting alone. And the p-value is significant as well here for the heterogeneity. And look at that. So the effect size for the community-based was -4. That is gigantic. And for the corrections, a -0.5, which is great. A moderate effect size. All right. So that shows you the basics of CMA. And you should be good to go for entering in your data. And I've given you some hints on interpreting your data and where to focus. And good luck this week.